Hey guys, I hope y'all are doing well today. We are going to go over isotopes in terms of their protons, electrons, and neutrons, and we're going to learn how to draw Lewis dot structures. Alright, so starting off, we're going to look at our Bohr model, which is how we draw the electrons around the atoms. Alright, so your Bohr model is how you draw your electrons around the atom. Your protons and neutrons are going to be in your nucleus, so let's imagine this is a bunch of protons and neutrons. And then your electrons go in your energy levels, which are going to be around your nucleus. So let's imagine we have our 3 energy levels. Your first energy level can only hold 2, you're going to have 2. Your second energy level can hold 8 electrons. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8. Y'all are going to have to bear with my drawings. I'm learning how to use this tablet. Your third energy level can also hold 8 electrons. You've got your 8 on here still. So you equal 18 electrons in total. And same thing as you go on. Fourth holds 32 total electrons in the entire atom. So you can get your energy levels, the number that you're going to have, from your periodic table. So you can see on your periods, numbers 1, 2, 3, and 4 actually tells you how many energy levels you're going to have. So phosphorus, for example, is right here, and it's in your third period level, which means it has 1, 2, 3 energy levels. So let's practice. We're going to draw a circle for our nucleus. This is for argon, which has an atomic number of 18 and mass of 39.948. So you have 18 protons, 18 electrons, and 22 neutrons. Your first energy level is going to have the 2 electrons, but you have 16 more. So where are you going to put that? You're going to put 8 on the next one, but you still have 8 more. So you add 1 more energy level, and that fills out your rings. Alright, so let's practice drawing fluorine. So fluorine has you got your protons, you have 9. For electrons, that means you also have 9. And your neutrons, you have 10. So you're going to start off with your nucleus, with your protons and your neutrons. And you're going to have your first energy level go around. And remember, we have 2 in our first energy level. So 9 minus 2, 7. So then we'll draw our second energy level. We have 7 that we need to fit in here. So we're going to draw 1, 2, 3, 4, 5, 6, 7. And that's correct. You got your 2, 2, 2, 2, 1. Ta-da! Your outermost energy level is what holds your valence electrons. So that's where we put our final electrons. So these would be your valence electrons right here on your fluorine atom. And to find out how many valence electrons each one will have, you can actually look at your group number. So for groups 1, 2, and 3, those all have 1, 2, and 3 valence electrons. For your elements on the right hand of the periodic table, you don't have 14, 15, and 16. You actually have 4, 5, and 6 valence electrons. So for phosphorus, you would have 5 valence electrons. And you can see that over here. See, 2, 3, 4, 5. So let's draw out some Lewis dot structures, and these are found on your notes packet. On page 7 of your notes packet, you'll find this same diagram. We're going to draw out these elements. So for lithium, you have 1 valence electron because it's in group 1. So we're going to draw 1 dot. For beryllium, we have 2 valence electrons because it's in group 2. And so on and so forth. Boron will have 3, 1, 2, 3. Carbon will have 4, 1, 2, 3, 4. Nitrogen will have 5. So you've got 1, 2, 3, 4, 5, and oxygen has 6. 1, 2, 3, 4, 5, 6, and fluorine has 7, and neon has 8. So remember we said that your shells beyond the first one can only hold 8 electrons. Notice that neon has all 8. And we're going to go to the next slide. Check. And that's correct. You had 1, 2, 3, and so on. So here we're going to practice drawing the Lewis dot structure for argon, aluminum, sodium, and magnesium. So for argon, we have 8. It is a noble gas. For aluminum, we have 3. For sodium, we have 1. And magnesium, we have 2. So let's go ahead and draw that out. We'll do AR. Argon has 8. So we're going to go ahead and draw 8, 2, 3, 4, 5, 6, 7, 8. Aluminum has 3. So 1, 2, 3. Sodium has 1. Boop. And magnesium has 2. And check that. And that's correct. All right, now we're going to go over isotopes. Isotopes are different forms of the same element. So carbon 12, 13, and 14 are still also carbon. They just have a different number of neutrons. Notice this one has 6, this one's got 7, and this one's got 8. So the isotopes have the same number of protons, but their masses are different because they have different numbers of neutrons. All these isotopes of carbon actually have the same chemical properties. Your isotopes have the same number of protons, but their masses are different, having different numbers of neutrons. So the only thing that changes is their mass number. Isotopes of carbon have the same chemical properties. So since we're not changing the amount of protons, we're only adding neutrons. That is why our mass changes. But it still remains the same element, and it has the same chemical properties. And you don't have very many isotopes for one element. See, hydrogen has 3. Your mass number of an isotope is going to be the number after the element's name. And your mass number is your sum of the protons and neutrons. So your mass equals your protons plus your neutrons in the nucleus. So you got potassium 39 with 19 protons, 19 electrons, which means it has 20 neutrons. Potassium 40 has 19 protons, 19 electrons, and 21 neutrons. And then potassium 41 has 19 protons, 19 electrons, and 22 neutrons. All right, so let's do some examples. You have phosphorus 32, which means if you look at your periodic table, phosphorus has an atomic number of 15. So we have 15 protons, 15 electrons, and we have 32 minus 15 equals 17 neutrons. Sulfur 34 has 16 protons, 16 electrons, 34 minus 16, which is 18 neutrons. Fluorine has 9 protons, 9 electrons, and 18 minus 9, not 19, 9, has 9 neutrons. And then bromine has 35 protons, 35 electrons, and 81 minus 35 equals 46 neutrons. And we can just check our work. And that's correct, 36, 9, 18, 17. So your isotopic symbol is what we would use to show your isotope's mass over its atomic number. It's just a simple way of displaying it. And the way we would write this out is you have your chemical symbol, which right here we can see helium, your mass number over your atomic number. So here this would have a mass number of 4 and an atomic number of 2. So here's our first example. We have copper which has a mass number of 63, an atomic number of 29. So we can say it has 29 protons, 29 electrons, and 63 minus 29 is 34 neutrons. Our next example is krypton, which is a noble gas. And here we can see its mass number is 78, its atomic number is 36. So protons is 36, electrons is 36, and 78, your mass number, minus 36 equals 42. You have 42 neutrons.